Hello, my name is Keshwani. This is Keshwani, Keshwani. I have been solving math problems out of this book here, the GMAT review, the official guide. If you do not own this book, buy one immediately. You will find it at mba.com. The problem that I'm about to solve is the one that you will find on page number 172, problem solving 152. As I'm talking to you, I was looking for a problem here. Here's I just found it. Just search for this tag, GMAT, page 171, number 145. Problem solving 145. While you're watching this video, also watch this video. Just put in this tag, just search for this tag here. Type in GMAT. This is the notation that I use. GMAT dash P for page 171 dash problem solving 145. Watch this video along with this video that you're watching, and you will find something helpful in that one that will help you here. Let's solve this problem. It says the shaded portion of the rectangle shown above represents a flower bed. If the area of the bed is 24 square yards, all right, the area of the bed is 24 square yards. Let me draw the picture. X, Y, and Z. And we know that the area of this thing is 24 yards. 24 square yards rather. The question simply is, we are told that x equals y plus 2. The question simply is, what is z? This is what we have to find out, z, this guy. Let's get going. We know that the area of the triangle is, area of this flower bed is 24 square feet, or square yard, or square meter, it doesn't matter. Or square banana, it doesn't really matter what the unit is. It's 24. How does one find the area of a triangle? The area of the triangle is, let's give this triangle name so I can talk about it. Let's call it A, B, C. Let's go. So the area of the triangle ABC is 1/2 base, which is y, times height, which is x. And that I'm told is 24. So 24 has to equal 1/2 y times x, which I'm told is equal to y plus 2. So I'm going to substitute here y plus 2. Let's continue then. How do I get rid of this 2? Multiply both sides by 2. Multiply both sides of the equation by 2. And so I end up with 48 equals y times y plus 2. Very good. Now, when you get up to here, you could actually open the parentheses and you get y squared plus 2y, and you can set it up as a standard quadratic equation. For those of you who know what I'm talking about, you could actually waste your time by setting it up as y squared plus 2y minus 48 equals to 0, and then you factorize and solve the solution. You could do all of that. Or here's the quick bit. Ask yourself, can you think of two numbers? Can you think of two numbers so that when you multiply them, you get 48? But the two numbers have to be such that this number has to be 2 more than this number. Let's try some. I'm going to play around. I know I need 48. Well, I know 24 times 2 is 48. 24 times 2 is 48, but the difference is not 2. This is 2 much bigger. So let's reduce it. How about 12 times 4? 12 times 4 is 48, but again, difference is not 2. Difference is 8. How about 6 times 8? Ah, voila. There you go. 6 times 8. There you go. That tells me that y is 6 and y plus 2 is 8. There you go. So there you go. Your y is 6. We just found it. Y is 6. Let's put it here. Y is 6. The y is 6, and since x we are told is 2 more than y, since y is 6, this would have to be 8. This marker is driving me crazy. This is 8. Now, the problem is going to start now. You just At this point, you simply solve this triangle ABC using a Pythagorean theorem, which tells you that x squared has to be 6 squared plus 8 squared. 6 squared is 64. Oh, sorry, 6 squared is 36. 8 squared is 64, which gives you 100, which tells me that z would have to be 10. That's one way of doing it, to figure out z. Let me look at the camera here and see if I have the time to talk about the other thing that I want to talk to you about. Oh. I'm only 5 minutes into the tape here, so I'm going to talk about a little bit different here. I don't know if I should erase this or not. I'm going to erase this thing. I need room. Where should I do it? Let's erase this part here. We don't need this. Look at this triangle. Do you recognize this triangle? This side is 6, this side is 8. What could be this side? Let's take a look at it here. A right angle triangle. This side is 6, this side is 8. What is this side? Can you figure out this missing side without doing any work? This is a special kind of triangle. This is a triangle that you should know. This is what is known as a 3-4-5 triangle. A 3-4-5 triangle. A 3-4-5 triangle is so called because 3 squared plus 4 squared equals 5 squared, which is a hypotenuse. This thing, 3-4-5 triangle appears very often in the exam, but when it appears, most of the time it is incognito, it's in disguise. That is a 3-4-5 triangle. I didn't have to do any of this thing if I were able to recognize right away that that's a 3-4-5 triangle. Why is it a 3-4-5 triangle? Because this is 3 times 2, that is 4 times 2. Therefore, it tells me that the missing side has to be 5 times 2. If I were able to recognize that right away, I could have saved myself all of this work. I could have saved myself all of that work. But anyway, that's one way of doing it. Let me give you a couple of more examples of a 3-4-5 triangle. Again, let me check the camera. Let's do a couple of more. A 3-4-5 triangle. See if you're able to recognize them. I don't want to erase any of this thing, but that's because it belongs with the problem. Let's do one more. A 3-4-5 triangle. For example, if I tell you that this is 20 and this is 25, what is the missing side? If you're able to recognize it right away, then there is another 3-4-5 triangle incognito. Why? Because this side cannot be 5. It has to be either a 3 or a 4. 3 or a 4. So I was wrong here. Let's put this. I made a mistake here. Let's say if this is given to you like this. What is the missing side? You could actually sit there and do it with the Pythagorean theorem. This is a right angle triangle. You could do it with the Pythagorean theorem and say to yourself, 25 squared equals 20 squared plus x squared and solve for x. No big deal. But here's a quicker way. If you're able to recognize that this 25 is just 5 times 5. This 20 is 4 times 5. This is 4 times 5. This is 5 times 5. So this missing side would have to be 3 times 5. The missing side is 15. That's all. I don't have to do anything. Let's do one more. Let's do one more quickly. Make up something interesting. 21 times root 3. 28 times root 3. Can you tell me what this missing side is? That's a 3-4-5 triangle incognito. How do I know that? Because this 21 is simply 7 times 3. This 28 is simply 4 times. This is 7 times 3. This 28 is simply 7 times 4. Therefore, this missing side would have to be 7 times 5. But then there is a root 3 here and root 3 here. So this has to be root 3 as well. So that's a 35 times root 3. That missing side is 35 times root 3. And if you knew this thing, this is incognito. It's a 3-4-5 triangle. A 6, which is 3 times 2, and 8, which is 4 times 2. And therefore this missing side would have to be 5 times 2. The answer is 10. The answer is E. I hope you found this helpful. If you wish to buy my DVDs, in which I show you the solutions to all the problems, or if you wish to hire me for personal private tutoring, in either case, go to my website at www.prepforgmat.com and send me an email. Alright? Thank you.